Hello class 11. In this video we are going to look at the topic motion of a body down an inclined plane. Now basically there are two cases for it. The first case, when the body slides down the inclined plane due to its own weight, and the second case, when the body slides down the inclined plane when we apply an external force to the body. That case we are going to discuss later. For now, let us focus on this case, which is when the body slides down the inclined plane due to its own weight. Now, in the last video, we spoke about something called angle of repose. And of course, remember, I represented angle of repose simply by theta. Okay? For now, let us consider angle of repose to be theta c. So instead of simply writing theta for angle of repose, let us write theta c for angle of repose. Now, we saw in the last video, for the case of angle of repose, that is when the body is on the verge of sliding down. Okay, what happened was, we broke the weight of the body into two mutually perpendicular components, mg cos theta and mg sin theta, and we saw that mg sin theta component was balanced by the force of limiting friction, FFS, and mg cos theta was balanced by the normal reaction of the body. So we saw that in the last video. Now our case is a slightly different one, because in this case the angle of inclination theta is greater than the angle of repose. Now at the angle of repose, I again repeat, the body is on the verge of sliding down. So when I slightly increase my angle of inclination theta and I make it greater than the angle of repose, then what happens? The body starts sliding down, of course. And the body sliding down the inclined plane in this case is due to its own weight. Remember that. Okay, because we are not pushing the body from above here, because of which the body is sliding down. The body simply slides down when we make theta the angle of inclination greater than angle of repose due to its own weight. So to say, our body is sliding down now. Alright? Now, since the body is sliding down, there of course is a force of friction that comes into play between this body and the surface of the inclined plane. And the force of friction no longer is now static friction, mind you. It is not limiting friction. The force of friction that acts over here at the point of contact with the two bodies is F of K. That is the force of kinetic friction. To be more precise, it is the force of sliding friction in this case, mind you. So, what do we have here? The body slides down because the mg sin theta component is pulling the body down. Alright? The weight of the body is mg. Now, if the angle of inclination is theta, then this angle also has to be theta. I showed you in the last video. Okay, so if this angle is theta, then this component is mg cos theta, which is balanced by the normal reaction R. Okay, and this mg sin theta component of the weight of the body, it is in this case greater than the force of friction that acts, and thereby the body moves down the inclined plane. Alright, so for this case, what is the scenario like? The scenario is like this. Let us look at the balancing of the different forces. So mg cos theta and R, they balance each other out. Mg cos theta and R, they cancel each other out because they are equal and opposite to each other, and they act along the same straight line. So therefore they cancel each other out. So to say mg cos theta is equal to R, or simply we can write mg cos theta minus R is equal to 0. From here, of course, we get mg cos theta is equal to R. This is your, say, equation 1. Now equation 2 gives us mg sin theta. It is greater than the force of kinetic friction acting right now, don't forget, minus F of K is equal to the weight of the mass of the body is m. And let us suppose A is the acceleration acting on the body. A is the acceleration on the body, produced on the body. Okay, alright, since mg sine theta and f of k, they are unbalanced, so to say, thereby the body slides down, okay, and it starts accelerating, and the acceleration produced is a. This is our equation number 2. Now, we have learned, since the force of kinetic friction is equal to mu k into, we have learned this is the law of kinetic friction. Okay, this is the law of kinetic friction. This we get from the law of kinetic friction. How do I spell friction? F-R-I-C-T-I-O-N. Okay, so we substitute this value of f of k in equation number 2, and let us see what happens. So you can pause the video and copy up to here, class 11. Okay, so I'm erasing this part and I'm erasing these equations. So substituting value of f of k in equation 2, what do we get is mg sine theta minus mu k into r is equal to m into a, or we substitute the value of r now from equation number 1, which is mg cos theta. So therefore mg sine theta minus mu k into mg cos theta is equal to m into a. Alright, so I'm erasing the lower half now. Okay, class 11, you all can pause the video and then copy the things. Alright, so of course we can take out m common on the left hand side, and the m on the left hand side and the m on the right hand side, they cancel each other out. So we get, so to say, a is equal to g sine theta minus mu k g cos theta. So this is, so to say, the value of the acceleration with which the body slides down the inclined plane. Alright? Okay, now we can do one special case. You can pause the video again and copy. Alright, I'm erasing. So I'm erasing. Now one special case, that is, if the body slides with a constant velocity, this means what? That is, what happens to the acceleration? The acceleration is 0, since the body is sliding down with a constant velocity. Then what happens to this equation? Let me again erase this part. I hope you are pausing the video and copying. Alright, so acceleration being 0 means g sine theta is equal to mu k into g cos theta. Alright, so this g and this g, they divide each other out, and thereby we get, therefore, mu k is equal to tan of theta. Okay, class 11. And by the way, what is mu k? Mu k is your coefficient of kinetic friction, don't forget. So the coefficient of kinetic friction is equal to the tangent of the angle of inclination. This is a very short video regarding kinds of friction, class 11. We've already seen that friction can be of 3 kinds: static friction, sliding friction, and rolling friction. This two together is also called kinetic friction. Kinetic means in motion. Okay, and do remember, static friction is greater than sliding friction, which is greater than rolling friction. So to say, it is easiest to roll a body than to slide it. The early men, our forefathers, our ancestors, they also understood that it is much more easy to roll a body than to slide it. Alright, therefore they devised wheels. Okay, although they did not understand, they had no clue whatsoever about friction. Alright, they didn't understand that sliding friction is greater than rolling friction, but they understood it is easier to roll a body. That is why wheels have been devised, which is a very, very important and essential part of our everyday life. Okay, now I also have made a demo video to demonstrate static friction is greater than sliding friction, which is greater than rolling friction, actually for class 6s. Okay, but I will send you the link, you can check that video too.